Let's continue from there. So we were talking about this relation. Everyone, can you see my screen? Yes. Aisha, Galvin, Ziana, Harshit, Maha. Can you see my screen?
Yes, ma'am.
Yes.
Okay, let's continue from there. We have already discussed till here. Okay, how to find LCM, how to find SCF. Now we were talking about one relation, that is LCM into HCF is equals to one number into another number. What is this one number, another number? One number means the number by using, like, we must be having two numbers, and by using both the numbers prime factorization we are finding the LCM, then we are finding the HCF. That number only we are going to use on the other side. We are going to take product of the two numbers on the other side. Okay, so basically instruction will be like this. Instruction will be given to you. Find the LCM and HCF of 26 and 91 and verify that this formula LCM into HCF is equals to product of two numbers. Please find the LCM and HCF at first, then we will be doing the verification. That is it true that LCM into HCF is equals to product of two numbers? Please do it. Find the LCM and HCF of the given number. That is 26 and 91. I have written over here this one and this one. Yes, please do it. Yes, Afnan, Aisha, Galvin, Ziana, Harshit, Maha. Whoever have joined just now, I am saying that this is the formula we already know. Okay, if you don't know, please note down this formula, that LCM into HCF is equals to one number into another number. That means product of two given number. Okay, on the basis of this formula only, we have to first find LCM and HCF, and then we have to do the verification also. That is LCM into HCF is equals to product of two numbers. That we have to verify for this particular question. So at first we are going to find the LCM, then we'll be finding the HCF, and then we will be doing the verification. Verification we'll be doing together. You just find LCM and HCF and let me know what are you getting.
Ma'am, for the HCF I got 13 and for the LCM I got 182.
Okay, for the HCF you got
13
and LCM
182.
182. This Maha, you got this one, right, Maha?
Yes, ma'am.
Okay. I have kept your response over here. Rest of the student, please find it and let me know what are you getting.
Ma'am, I'm also getting the same answer.
Okay, you are also getting the same answer. Who said?
Ma'am,
Harshit. Okay, Maha and Harshit. These two students are getting the same answer.
Ma'am.
Yeah, Afnan.
Ma'am, ma'am, this is Jenna.
Okay, Ziana. Yes,
Ma'am, I also got the same answer.
you are also getting the same, right, Ziana?
Yes, ma'am.
Okay, fine.
Ma'am, I'm also getting the same answer, ma'am.
Galvin is also getting. Okay, so who is left? Harshit, Ziana, Galvin, Aisha. You have not responded. Afnan, I'm waiting for your response as well. These two students, please let me know what are you getting. Then we will see.
Ma'am, same answer.
Afnan is also getting same. Aisha.
I'm also getting.
Yes, Aisha. I can't hear you. Are you saying anything?
Yes, ma'am. 182.
Okay, same answer you are also getting, Aisha?
Yes, ma'am.
Okay, so everyone is getting same. Fine. I believe that HCF is 13 and LCM is 182 because everyone is getting the same answer. Let's do the verification. Once we will do the verification, we will be sure that yes, this is what we are getting. So HCF we got 13, LCM we got 182. Here verification, for the verification formula is given, but the formula will not be given to us every time. So we must keep the formula in our mind that LCM into HCF is equals to product of two numbers. Okay. Let's do the verification. LCM into HCF is equals to product of two numbers. This is the formula. What is LCM? LCM is 182. What is SCF? SCF is 13. We will be doing the multiplication of 182 with 13. Please let me know what are you getting. 182 into 13.
2366.
2366, right?
Yes, ma'am.
Okay. Let's find the product of two number. That is, our first number is 26 and the second number is 91. The first number is 26 and the second number is 91. So we'll be doing the multiplication of this two number, 26 into 91, like this. Let's do the multiplication, 26 with 91, and let me know what are you getting.
Ma'am, the same number, 2366.
Okay, 2366. Rest of the student, are you getting the same?
Yes, ma'am.
Yes, ma'am.
Yeah, we are getting the same. Okay, so yes, we have done the verification also. So whenever the instruction will be like this, find the LCM and SCF and verify the relation between LCM and SCF and the product of two number. Maybe the for the verification formula will be given, or even if the formula is not given and if the instruction is asking about do the verification, we are supposed to do the verification by using this formula only. Okay, now once we know this formula, we will be able to do this question, where the question is given that HCF 306 and 657, these two numbers, HCF is 9. Find LCM of the same, that is 306 and 657. Whenever we are having this type of question, we are not going to do the prime factorization, and we will be finding the LCM by using the process which we were discussing yesterday, that First, we will be doing the prime factorization. Then we will see what is common. That one's maximum highest power we will take. And then remaining term also we will take. That process we are not going to repeat over here because HCF is given and LCM it is asking. That means we have to use the formula over here. Which formula? The same formula. By using this formula, we have done the verification. No, this formula we are going to use for finding the LCM. Okay, let's use the formula. The formula is LCM into HCF is equals to product of two numbers. The formula is LCM into HCF is equals to product of two numbers. LCM we have to find. We don't know what is LCM. HCF we know, that is given over here as 9. HCF of this two number is 9, that is given over here. We are writing 9 over here is equals to LCM we don't know. Product of two number means the two given number, that is 306 into 657. Please find the LCM from here by doing the calculation.
Ma'am, it is coming 22338.
Yes, what are you getting?
22338.
22338. That's what you are saying, Harshit?
Yes, ma'am.
Okay, let me write it. Rest of the student.
Ma'am, same answer.
Okay, same answer. Who said?
Ma'am, Afnan.
Okay. Harshit and Afnan, both the students are getting this answer. Rest of the student, please let me know.
Ma'am, this is Jana. I also got the same answer.
Okay, Ziana, you are also getting the same.
I'm also getting the same answer.
Maha
Ma'am,
is
I'm
also
also,
getting. Galvin
I'm
is
also
also
getting
getting
the
the
same
same.
answer.
Right? Okay, so Maya.
Ma'am, I'm also getting the same answer.
Okay, so Maya is also getting the same. So everyone has responded. Okay. So this is what we got as a LCM. Whenever HCF will be given, this formula we are supposed to use, and then we can find the LCM. Okay. And when two numbers will be given and it is clearly asked in the question that find LCM, that time we will be finding it by doing the prime factorization method. Fine. I was talking about you need to understand the concept of LCM and SCF so that you will be able to work on the expressions also. Whenever we'll be having expression, let me take that type of question over here. Just a second. Yeah, here I also want to mention that this formula which we were talking about, that LCM into HCF is equals to product of two number, it is only applicable for two integers. Okay, it is not applicable when we are going to find the LCM and HCF of three numbers. So for three numbers we'll be finding LCM, we'll be finding HCF the way we were doing. Let me give you one question. Meanwhile, please find the LCM. Find LCM and HCF of 17, 23 and 29. Okay. Again, I am saying that this formula which we were talking about, this rectangular box one, okay, this formula is only applicable for two numbers. LCM of two number into HCF of two same number is equals to product of two number. It is not applicable for more than two number. That is, here we can find the LCM of three numbers. We can find the HCF of three numbers. but there is no formula which will be applicable, just like the previous one. Okay, please find by applying the prime factorization method.
Ma'am,
Yeah.
ma'am, HCF I'm getting 1 and LCM is 11339.
Okay, LCM 11339.
Yes,
HCF.
ma'am. Yes.
Okay,
I'm also getting the same.
this one is Harshit's response, right? Yes, Maha, you are also getting the same.
Yes,
Ma'am,
ma'am.
HCF is 1 and LCM is 11339.
Ma'am, I'm
Okay.
also getting the same answer. Ma'am.
Afnan, Galvin, you both are getting same.
Ma'am.
Yes, Ziana, Aisha.
Ma'am, I also got the same.
Okay, Ziana, you are also getting
Ma'am,
the
I'm
same.
also getting the same answer.
Sumaya is also getting the same. Aisha,
Same answer, ma'am.
same. Everyone is getting same, right? You have done it by prime factorization method. Yes, I can see these three are prime numbers. So HCF will be 1. LCM we need to check by doing the multiplication. Okay. So if you all are getting the same answer, this will be the answer. Let's move ahead. Let me check it quickly. The LCM you have taken out correctly or not. Yes, this is the LCM we'll be getting. Okay. Okay, let's take the next question. The next question is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, okay, are composite numbers. Why these two are composite number? Why we are going to say that the first one is a composite number? Let me write the first one again. So it is given that the number which we are having is 7 into 11 into 13 plus 13. Is it a composite number? And if so, why? Anyone?
Ma'am, we can take common 13 years.
Yeah, Harshit, you are saying?
Yes.
Okay. Yes, we can take out 13 common. See, this one is one term because all are in multiplication. Multiplication means all are just attached with each other. It's a single term. Okay, so 7 into 11 into 13, it's a single term. And the next term is 13. So two terms we are having, 7 into 11 into 13, first term, 13, second term. In among these two terms, what is the common factor which can be taken? So can we say that 13 is the common factor which we can take from here, from this two terms, from these two underlined terms? Can we take 13 as a
Yes.
common factor? And if we can take 13 as a common factor, what will be remaining inside the bracket? So from the first term, from the first underlined part, that is our first term. From there, 7 into 11 will be remaining. And from the next one, what will be remaining? Only just, see, this was 13, okay? From the next one, just 13 is there, so 1 will be remaining, right? Here only, if we want, we can do the calculation after this, like the bracket term, we can again do the calculation. 7 into 11, 77, 77 plus 1 is 78. The bracket one, we can do the calculation, okay? Without even doing the calculation also, we can see there are two factors, okay? When we have done the factorization, 13 and one more number is there. Fundamental theorem of arithmetic also says that every composite number can be broken as a product of prime. That is fundamental theorem of arithmetic. And here what is prime number? What is prime number? And if I am writing a prime number 23, is it possible to do the factorization of this prime number? There is only one way to write it, 1 into 23. If we want to do the factorization of a prime number, there is only one way, that is 1 into 23 we can write. If we are taking a prime number 19, and if I am telling you to do the factorization of 19, so factorization of 19 will be, there will be no two number which will multiply together and will give 19 apart from just 1 into 19, right? But here we are getting, can you see, here we are getting two different numbers. Can you see? That is 13 and one more number. Two different factors we are getting, right? Apart from 1 and the number itself. So we can say it's not a prime number, it's a composite number. Yes or no? Because in the case of prime number, when we are having a prime number 17, let's do the factorization. There is only one way. We cannot break it. Okay? We cannot factorize it. There is only one way for writing it. We can write 1 into 17. Apart from this way, like we cannot do the factorization. However, if we are having a composite number, let's say 6, we can write it as a 2 into 3. We can also write it as a 1 into 6. That is okay. But we can write this 6 as a 2 into 3 also. Okay, this one is composite number. Similarly, if we will take any other composite number, let's say 21, we can write it as 3 into 7. Okay. So two different number multiplied together giving us 21. That means it's a composite number. In the case of prime number, we were not getting. While doing the factorization, it was not possible to do the factorization. And even if we tried, there was only one way, 1 and the number itself, right? But in our case, in our question, can you see we have got two different numbers while doing the factorization. This is just the factorized form. Factorized form. Be clear that something into something. That is factorized form. If I have to factorize this x square y, I would write x into y. This is the factorized form of x square y. If I have to do the factorization of 12, we can write 4 into 3. If we have to, we can also write 2 into 2 into 3. So these are the way of doing the factorization of 12. Okay. Similarly, can you see that our question, this two circled part 13 and the other bracket, this is nothing but just the factorized form. Getting it? Getting it?
Yes, ma'am.
Okay. So we are able to represent it as a product of two different numbers. Hence, it's a composite number. Yes or no? Can we say from here only it's a composite number? Or you can increase one more step. You can also do 13 into the bracket all together when we will do the calculation of the bracket by using BODMAS, multiplication first and then addition. So it will be 77. It will be 77 plus 1, that means 78. So product of two different number, obviously that will be a composite number, not a prime number. Yes or no? Getting it?
Yes, ma'am.
Everyone, is it clear? Afnan, Aisha, Galvin, Ziana, Harshit. Harshit, you said
Yes, ma'am.
already. Maha, Sumaya. Is it clear?
Yes, ma'am.
Yes, are you getting it?
Yes, ma'am.
Okay. Yes, anyone having any confusion over here? Similarly, can we show the other number which is given in the question? Can we say that it is a composite number or a prime number? Explain why the given number is a composite number. So yes, it is a composite number. We have to explain why. Okay, the other number which we are having as 7 into 6 into 5 into 4. Let me write it over here. 7 into 6 into 5 into 4 into 3 into 2 into 1. Let me check. This is what we were having. Yeah, plus 5. Plus 5. What can be done over here?
Ma'am, 5 is a common taking.
We can take 5 as a common. Yes or no? Can you see 5 over here, 5 over here? So we can take 5 as a common factor, right? What will be remaining in the bracket? If you are still getting
7
confused, then
into 6 into 4 into 3 into 2 into 1 plus 1.
exactly. Plus 1. Again, we have represented this as a product of two integers, okay, which is only possible for composite number. Hence, we can say this is a composite number. Yes or no? We can keep it over here only, or if we want, we can increase one more step. We can also write the bracket one. We can do the calculation and we can write it as a product of two integers, 5 into any other number, whatever number we'll be getting from here. However, from here only we can declare that it's a composite number, 5 into any other number. That is only possible for composite number. Okay. So this is how we will, this is how, if the number is given to us and if the question says explain why this and this are composite number, we can take, we can check whether is it possible to take out any common factor or not. If it is possible, then just a second. Yeah. So if it is possible, then we can say, yes, it will be composite number. How we are going to write it? So we can write it like this. Let me write the explanation. What the explanation we are going to give. This number, the given number, can be represented as product of two integers. Hence, the definition of prime number was now any number which has exactly two factors, one and the number itself. But this number will be having more than two factors. Okay. Hence, it will have more than Therefore, it's a composite number. Two factor for the prime number was the number 1 and the number itself. Okay, here we are having two different numbers. That means it will not be a prime number, it will be a composite number. This is how we can give the explanation that we are able to express this number as a product of two integers. Hence, from there only we understand that this number will be a composite number. It will have more than just two factor. Why we are mentioning more than two factor? Because we call the definition of prime number and composite number. The definition of composite number was any number which has more than two factor are called composite number. Any number which has exactly two factor, those numbers are called prime factors, prime numbers. Okay, so that's why we are mentioning it over here to declare that it's a composite number. Is it clear to everyone? Anyone having any confusion over here? Now let me take the question which I was talking about, LCM and HCF question from our previous year question paper. Okay, so the question can be like this. The LCM of two numbers is 48. The numbers are in ratio of 2:3. Find the sum of the numbers. Options are also there. Option A 40, B 32, C 28 and D 64. Please try it at first, then we will be discussing it. Okay, I'm giving you 2 minutes. Please try it at first. What the question says, the LCM of, just a second. Yeah, the LCM of two number is given over here. The numbers are in ratio 2:3. Find the sum of the numbers. That's it. Okay, please do try. Then we are going to discuss it over here.
Ma'am, option A.
Okay, option A you are getting. Who said?
Afnan, ma'am.
Yes, Afnan, you said.
Ma'am, option number A, Afnan.
Okay, Afnan. Option A. Yes, rest of the student, have you tried it? Yes, rest of the student, have you tried? Okay, let's do it over here. Let's see how can we proceed over here when we are having
option
this.
A.
Option A.
Yes, ma'am.
Afnan said, and Maha, you are also getting option A, right, Maha?
Yes, ma'am.
Okay. Okay, let's see whether it is option A or what. How we'll do when we'll be having this type of question. The LCM of two number is given as a 48. The numbers are in ratio 2:3. Whenever we are having the ratio, we can separate the terms of the ratio, but at the same time, we have to take a common term, common variable with both the numerator and denominators part or both the numbers. This one, the 2:3, the number are in ratio. The number are in ratio 2:3. So first one is representing first number. Next one is representing the second number. Basically, we are having the ratio between the numbers. If we want to get the number, can we say that the first number is 2x? Can we assume that our first number is 2x and our second number is 3x? Can we say that our first number is twice x and second number is thrice x? Yes, we can say, because while finding the ratio, we must this is the only way we can separate the ratio. We cannot say that the first number is 2, second number is 3. That we cannot say because it's a ratio. When I am saying the ratio of age, let's say Maha's age to my age is, it is, if I'm saying it is 1:3, that doesn't mean that she is 1 year old and I'm 3 years old. That doesn't mean. That is just the comparison of her age to my age. Okay. So when we are having the ratio, there is a representation, like the first term is representing the first number, second term is representing the second number, but without taking a common variable like x and x with both of them, or y and y with both of them, we cannot separate the ratio. You must have understood. I cannot say that her age is 1 and my age is 3 years old. That is incorrect. Okay. So this is just the comparison between two terms. Okay, first term and second term, first number and second number. This is just the comparison. Why we are multiplying the same variable with both the term? See, when we are having whenever in mathematics we are having a fraction, let's say a fraction I am having 25/10. Now we have learned that whenever we are having any fraction anywhere, we can reduce it to lowest term. So we cancel the common number. 5 times 25, 5 2 times 10, and 25/10. Previously the number numerator was 25 and the denominator was 10. That became 5/2. That's why whenever we'll be having this type of reduced form, 5/2 or any ratio we'll be having, that is the reduced form. Okay. That's why whenever we are separating them, we have to multiply a common number with both of them. We don't know what is that common number that we can multiply. So we are saying that x and x we can multiply with both the term. Because here, while having 5/2, you can see 5/2 can only become 25/10 again when we will multiply 5/2 with a common number. With a common number that we have already cancelled. That common number was 5. Can you see? We have cancelled this common number and then it became 5/2. Getting my point? That's why we say that whenever we are having a ratio, always separate it by taking a variable. But students don't understand that why we are taking the variable. So this is the explanation of that we have somewhere we have cancelled out a common number from the numerator and the denominator. And when we are directly having the ratio in hand, we don't know what was that common number which has been cancelled. That's why we take x and x, or maybe y or maybe z, any variable. Got it? So this is how we'll be having our first number and second number. Now, I was telling you to understand the concept of LCM, to understand the concept of HCF. By looking at this two number, can we say what is the LCM we'll be getting from here? Please let me know. If the first number is 2x and the second number is 3x, what will be the LCM? If the first number is 2 into x and the second number is 3 into x, what will be the LCM? What we do while finding the LCM, we search the common term. Yes or no? Common factor. Common factor over here, common factor over here. So can we see x and x is exactly common? So LCM will have x. And apart from that, all the remaining numbers, remaining term, that means 2 and 3 as well. So can we say directly that LCM is 6x? But the LCM is given already in the question. LCM is already given in the question, that is 48. So LCM 6x, which we are saying by taking both the number in consideration, 2x and 3x, LCM is 6x. That LCM, it is already given in the question, that is 48. 48 is the LCM of these two numbers, which are in ratio 2:3. So we can compare our LCM by 48, and here we will get the value of x. Here we will get the value of x. Now, if you will look at what we have to find here, the sum of the number. Okay. Once we are getting the value of x, directly we can find the sum of this two number. Right? Sum of the two number will be 2x plus 3x. Sum of the two number will be, sum of two number will be 2x plus 3x. Either you can just put the value of x and you can find the first number. Then you can put the value of x and you can find the second number. And then you can add those two numbers to get the sum. Or a quick way of finding the sum of two number is 2x plus 3x, that is 5x. And x value we already have found over here. That x value we can substitute directly to get the sum of two numbers. See carefully, it is multiple choice question. So we must give the time accordingly. Okay. Let's summarize everything what we did over here. The numbers are in ratio 2:3. Whenever we are having ratio in mathematics, we know we can separate them by multiplying the same term. Today we have discussed that also. Fine. So we can take first number as a 2x, second number as a 3x. Now, what is given in the question? What extra information is given in the question? The LCM of the two number is given as a 48. So recall the process of finding the LCM. What we were doing? We were doing the prime factorization, and then we were checking what is the common term. We were taking that common term. We were taking the highest power of the common term, and then we were also taking the remaining term. That was the process for finding the LCM. We are repeating the same process. And we realize that, okay, 6x will be the LCM. According to our assumption, LCM will be 6x. But in question, it is given that LCM is 48. So 6x is equals to 48 we have written. Okay. From there, we got the value of x. Once we got the value of x, directly we can find the sum of the two number. Let me check. Few students have responded that the first option is the correct option. So 48 by 6. 8 times 48. X value we got 8. Yes. We are getting 40, which is option number A. Is it clear to everyone? Please let me know. Is it clear?
Yes, ma'am.
Okay. Let me take another question. Still, if anyone is having any doubt, please let me know. Okay, one more question is there. I'm taking this question over, writing this question over here. First think about it, then we'll be discussing this question. Okay, there is a circular path. Around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time. And go in same direction. After how many minutes? Meet again at the starting point. Let's see what the question says. Okay, let's cover it. So here the question says there is a circular path around the sports field. Sonia take 18 minutes to drive one round of the field while Ravi take 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? If we are having this type of question, we don't have to plot the diagram. We don't have to understand it in detail. Only we have to see if we are having this type of question where two person are starting working at a particular on the same project and both are taking their own time, and finally we have to see that at what time again they will meet, or few bells are there. Suppose there is a bell A, bell B, bell C. All the like bell A is ringing at a particular time, bell B is ringing at a particular time, and their interval is given that this is the interval. If we are having this type of question, definitely that question is from LCM and SCF chapter, and we don't have to see plot the diagram and understand what exactly the question is talking about, what exactly the story is saying. We directly have to find the LCM over here. Okay, so whenever we will be having this type of question where this type of at last the question is asking about, see, after how many minutes will they meet again, after how many minutes will they meet again, after how many minutes again all the bells will ring together, after how many minutes two person who are starting at the same point at the same uh, just taking the revolution or covering a certain distance, same distance both are covering, having their own speeds, and again after how many minutes they will meet. If this type of question we are having, then definitely we have to find the LCM of two given number in the question, or LCM of 3 given number, 4 given number, whatever the numbers you can see in the question, that numbers LCM we have to find. Here 12 minute is one of the number I can see in the question, and what else apart from these all the wording I can see 18 minutes. So directly we can go ahead and we can find the LCM over here. Okay, this is 18 and 12 LCM. Whatever will be the LCM, that is the time, that much minute they will take to meet again. Okay, one more thing I want to add over here. Please give the assessment today. Okay, so this is the question. If this type of question we are having, which is related to bell, which is related to train, which is related to person, so here we have to find the LCM. Now in the question, if highest word is mentioned, highest maximum word is mentioned, and a story is given, that means there we have to find the HCF, highest common factor we have to find. And if in this type of word problem, if least word is mentioned, lowest word is mentioned, minimum word is mentioned, that means you have to find the LCM in that type of word problem. Okay, today you will be able to give the assessment which is related to fundamental theorem of arithmetic. Please give the assessment and let me know if you are having any doubt over there. Just give me a second. Let me inform